My name is TP Mulati, and in this session we'll be discussing questions involving areas. That's areas of circles, quadrilaterals, and other irregular shapes. Okay, now let's start. So the first question says, 6 circles, each with radius 2, are arranged in 2 rows of 3. Okay, they touch each other enclosing the region shown. Find the area of the region. Okay, so we can see there that we have a half circle and we also have a half circle there. So these 2 half circles will obviously make a full circle. Let's just color them in. So that half circle and this half circle here, they'll make one full circle. Okay, so we have the area of this shape will be pi. They told us the radius is 2 squared. We need to add something. So let's look at this area here in the middle. We can construct a rectangle like this. And now this rectangle has 1, 2, 3, 4 quarter circles, which will make one full circle, by the way. We know that the radius is 2. That means this area here will have 4 units because it's a diameter 4, and that will be 2 because that's a radius, and that will be 2. This area here will also be 2. That will be 2. Okay, now we have a rectangle of side 4 plus 2 plus 2, which is 8, and the other side is 4, which is 2 plus 2. So we can add in bracket 8 multiplied by 4, but we need to subtract the area of 4 quarter circles because those are outside of our region here. So 4 quarter circles will make one full circle. So we are subtracting one full circle of pi 2 squared. Okay, now this will be equals to pi 2 squared. Will cancel out with that pi 2 squared. So the area of this will just be based on 8 times 4, which is 32 square units. Okay, so sometimes you are required to divide your shape into smaller parts that are easier to deal with. Next question says, in the figure alongside, 4 small equal circles are circumscribed by a larger one. What is the ratio of the sum of the areas of the 4 smaller circles to the area of the larger one? Okay, now let's look at this problem. So what they want here is the ratio of the sum of the areas of the smaller circles to the area of the larger one. Okay, so we know that the area of a circle is given by the formula pi radius squared. Okay, so we'll take the area of large circle to be pi with a capital letter R squared, and the area of smaller circle to be pi with a small letter r squared, just for calculation purposes. Okay, now we do not have the radius of the smaller circle. We don't have the areas of the larger circle either. So because we want the ratio, we can just assume something to be 1. So in this case, let's assume small letter r to be 1, meaning let's assume the radius of the smaller circle to be 1. Okay, now if I add the centers to these smaller circles, I can construct a figure like that. Okay, now what we notice about this figure is that all sides are equal. Okay, because we assume that the radius of the small circle is 1. So that side there will be 2 units, that side will be 2 units. So actually what we have constructed here is a rhombus. Okay, now if we further construct the diagonals of this rhombus, we can see clearly that this becomes a square because the diagonals by symmetry are equal, they are the same. So a rhombus with equal diagonals is a square. Okay, just remember that. Rhombus with equal diagonals is a square. Now, we know that each of this side of this rhombus is 2 units, right? Because we assume that the radius of a smaller circle is 1, so that will be 2. That will also be 2. That means by Pythagoras, we can actually find the length of this diagonal here. Okay, so by Pythagoras, the length of that diagonal will be, let me just write it here, will be equal to the square root of 2 squared plus 2 squared, which we get square root of 8. Okay, now if we look at this diagram, if I construct another line from the center to the circumference of the larger circle, from the center there to the circumference of the larger circle, what I seem to be adding to this diagonal is 1 and 1, because the radius, these are both the radii of the smaller circle, so they will make this 1 and 1 added to this diagonal. Then we have a diameter of that larger circle. Okay, so now the diameter of the larger circle, let me just call it capital letter D, will be equal to root 8 plus 1 for that, plus another 1 for that. Okay, so 2, 1, so we get 2 plus root 8 as the diameter. Now, that means the radius of the larger circle will be equals to the diameter divided by 2, so it will be 1 plus root 2. Okay, because remember, square root of 8 is the same as 2 root 2. Okay, let me just write it here so that you remember. Square root of 8 is the same as 2 root 2. So if I divide it by 2, I only get root 2. Okay. Now, let's find out what the ratio is. Okay, so they said they want what? The ratio of the sum of the areas of the smaller circles to the area of the larger one. So we want sum of the areas of the smaller circles. So it will be 4 multiplied by pi 1 squared, because the area there is 1, divided by pi multiplied by 1 plus root 2 squared. Okay, if we do that, we get pi cancels pi, and we are left with 4 divided by, so we multiply this out by using FOIL, we get 1 plus 2 root 2 plus 2, and our answer here becomes 4 divided by 1 plus 2 is 3 plus 2 root 2. Okay, so as we can see, sometimes we are required to construct some lines if we can solve areas easily. Okay, and that helps us a lot in terms of imagining what the problem looks like. Okay, this question says one side of a triangle has a length 8 and the second side has a length 5. What is the maximum possible area of the triangle? Okay, now this question requires you to know the area rule. Okay, so some of you might be familiar with the area rule, but if you're not, that's okay. I'm just quickly going to explain it. So suppose we have a triangle and we know this side B and we know this side A, and we know the angle between the triangle, which is theta. Okay, let me just construct the perpendicular height here and call it H. Now we know that in any triangle, the area is equals to half base. In our example, base is A multiplied by the perpendicular height H. Okay, but if you remember from trigonometry, this angle here, the opposite side to this angle here is H, and B is your hypotenuse. That means sine of angle theta is equals to the opposite, which is the height H, divided by the hypotenuse, which is B. And now we can solve for H and say H is equals to B sine of theta. Now we can replace H in this formula here, and we would have the area is equals to half A multiplied by B sine theta. And this here is what we call the area rule, okay, which works when calculating the area of a triangle and you're given two adjacent sides with the angle between them. Okay, now let's go back to our question. Knowing that the question says in a given triangle, we have a triangle and one side is 5, the other side is 8. Okay, so if we assume theta to be the angle between these two sides, then we will have the area is equals to half multiplied by the base, which is 8, multiplied by 5, multiplied by sine of theta. Okay, from this equation here, because this equation here, it says A and B are the two given sides and theta is the angle between them. Now, if we simplify this further, we get half of 8, which is 4 multiplied by 5, we get 20. So we get 20 sine of theta. Now, the maximum of this triangle is determined by this here, sine theta. Okay, because 20 is fixed, it cannot change. Okay, now what is the highest possible value for sine theta? The highest possible value for sine theta is 1. If you would remember the sine graph, which looks something like that. So from the sine graph, we have a maximum here. Okay, and the maximum here, what will be theta when we have the maximum of sine of an angle? Theta here must be 90. If theta is 90, then sine theta is at a maximum. Okay, now we can see that the maximum here of the maximum area of this triangle will be achieved if theta is equals to 90. But if theta is equals to 90, what is sine theta? If theta is equals to 90, then sine theta is equals to 1. Okay, so the maximum area of this triangle will be equal to 20. And that happens when theta is equals to 90 degrees. So that's the maximum. Okay, this problem says ABCD is a rectangle with AB equals to 8 and BC equals to 14. A strip of which 2 has an edge on AD and the other on BC. Determine the maximum area of the strip. Now here's our rectangle ABCD here, and here's our strip with a width of 2. Now we need to construct these two opposite sides in such a way that they have the longest length as possible. Okay, so let me just construct that quickly. Okay, here's our rectangle, and I've constructed these two opposite sides of this strip in such a way that they have the longest possible length. Okay, now I'm just going to call this here E. I'm going to call that one the F. Okay, so we know that BC here is equals to 14. Okay, so I'm going to say BE is X. That means EC there is 14 minus X. Okay, now Let's use Pythagoras to find the length of AE. So AE squared will be equals to x squared plus 8 squared, which AE will be the square root of x squared plus 8 squared, which is 64. So we know the side here, which is A, is the square root of x squared plus 64. Another thing that we must notice is that this right angle triangle ABE is exactly the same as this right angle triangle CDF there. Okay, which is very important. So our width of the strip here is 2. Let's not forget that. Now, from here, we know that the area of the entire rectangle, the area of the whole rectangle here, will be equals to 8 multiplied by 14. Okay, and this will be equals to 2 of this right angles triangle here, which is this one and that one there. So we have 2 multiplied by the base, which is x. Sorry, it's half, multiplied by the base, which is x, multiplied by the perpendicular height of 8, and we add the area of a strip. If you look at this strip, we can notice that this strip is a parallelogram because this side here is parallel to this side, properties of a rectangle, and this side here, it is parallel to that side, assuming that the width is 2 all throughout the strip here. So area of a parallelogram is given by base times perpendicular height. So it will be base times perpendicular height here. So we take the base to be x squared, the square root of x squared plus 64, and our perpendicular height to be 2. Now, let's solve this equation so that we can find x. 8 times 14 is 112, which is equals to here 2 cancels the half, and we are left with 8x plus 2 square root of x squared plus 64. Divide everything by 2, then we get 56 minus 4x will be equals to the square root of x squared plus 64. Okay, it's very important that you learn how to solve the square root equations. The trick is just to isolate the square root and square both sides of the equation. So from here, we will square both sides of the equation so that we can get rid of that square root. And 56 squared is equal to 3136 minus, this is just the normal FOIL, 56 times 4 multiplied by 2, which is a negative 448, and that's plus 16x squared will be equals to the square there, just takes out that square root, and you are left with x squared plus 64. Simplify this further, we get 16x squared minus x squared, which is 15x squared minus, should be an x there, minus 448x, and 3136 minus 64 will give us plus 3072 equal to 0. Okay, from here we can either use the quadratic formula or factorize. We'll choose to factorize, and our first factor is 5x minus 96 and 3x minus 32. Okay, which therefore x will be equals to 96 over 5, or x will be equals to 32 over 3. Okay, now notice that this value here is greater than 14. Okay, and we know that the length of this little side here must be 14 minus x. So this cannot be the solution. This cannot be the solution. This here is our solution for x. Now, the question says determine the maximum area of the strip. And we know that the strip is a parallelogram. So area of the strip will be equals to base multiplied by the perpendicular height, which is equal to, so we find our value of x. So our base here is 14 minus x. We just want to run away from using the square root there. So we'll take this as a base, 14 minus x, and 8 as our perpendicular height. Okay, so this becomes the base, which is 14 minus x, which is 32 over 3, multiplied by the perpendicular height, which is 8. And if you solve that, you get an answer of 80 over 3. So in this question here, we are given a diagram and we have a right angle triangle here with a line drawn from the vertex of the right angle perpendicular to the hypotenuse, and they want us to calculate the value of h. Okay, so usually when we see right angle triangles, first thing that comes to mind is the theorem of Pythagoras. Okay, but looking at the whole thing, we have this side as 6, the hypotenuse is 10. Automatically we know that this side here should be 8. Okay, now I'm going to divide this triangle into 2, which is the red triangle here and the green triangle there, and just name this A, B, C, and D. Okay, now from ABD, if we use Pythagoras, we get 8 squared is equal to h squared. I'm just going to name this side here x, this one here y, plus x squared. So if I solve for h squared, I get h squared is equals to 64, because 8 squared is 64, minus x squared. Okay, and let me just underline this as our equation 1. And from the green triangle, I will get 6 squared is equals to h squared plus y squared, which if I solve for h squared, I get 36 minus y squared. Okay, so now I will equate equation 1 and equation 2 because they are both equals to h squared, and I get 64 minus x squared is equals to 36 minus y squared. Okay, so I'm going to manipulate this a bit. So if I bring the 36 this side and the x squared that side, I end up with 64 minus 36 is equals to x squared minus y squared. So 64 minus 36 is equal to 28. So I get 28 is equals to, I will factorize the right hand side into x plus y, x minus y, because there's a difference of squares. But I know already that x plus y, from our diagram here, x plus y is 10, right? So I will substitute 10 for x plus y. So they get 28 is equals to 10 multiplied by x minus y. And I get x minus y is equals to 28 over 10, which is 2.8. So I can use 2.8 there. And I also know there's another equation that I know that says x plus y is equals to 10, which is just the equation for this side here. Okay, x plus y is 10. You know that. So if I add the two equations, I'm going to add these two equations here. So x plus x, I get 2x. Negative y plus y gives me 0. 2.8 plus 10, I get 12,8. Divide both sides by 2, then x is equals to 6,4. Okay, now I need to go back and substitute my x to find h. We know from equation 1, h squared is equals to 64 minus x squared. So h squared is equals to 64 minus x squared. So just to make the calculation easier, I'm going to factorize this into 8 plus x and 8 minus x. And if I substitute my x, I get 8 plus 6, 4 and 8 minus 6, 4. So this will give me 14,4 multiplied by 1,6. Okay, but remember this is all equals to h squared. And this I can simplify further into 144 divided by 10 multiplied by 16 divided by 10, which I can simplify into 144 multiplied by 16. Sorry, this should be 10 by 16 over 100. Okay, so if I take the square root of that, which will then be equals to h, I get square root of 144, which is 12, multiplied by square root of 16, which is 4, divided by 10, and then 5 goes into 10 twice, or 2 goes into 10 5 times, and 2 goes into 4 twice. So I end up with 2 times 12, which is 24, divided by 5. Okay, so if you wanted to go the Pythagoras route, this is how you would do it. Now, let's discuss the next method. Now, this method is much more easier than Pythagoras because you run away from a lot of algebra. So if we take the area, we know that this is 8 from Pythagoras. So I'm still going to name this ABC. Okay, now if we take the area of the entire triangle here, we get the area is equals to half base 8 multiplied by perpendicular height 6. But we can also write this as half, the base is 10, and the perpendicular height is h. Okay, and from this, you just solve for h. Okay, and then we have what? 4 multiplied by 6, which is 24, will be equals to half of 10, 5h. Then h is equals to 24 over 5. Same as same answer we got in the previous method. Okay, this one is much more easier. Let's look at the last one. Okay, so in this last method, I'm going to use trig. So let's assume that this angle here is theta. So sine of theta would be equals to the opposite, which is 6, divided by hypotenuse, which is 10. But this is also equal to, if we look at only this triangle here, so this will be equal to the opposite, which is h, divided by the hypotenuse, which is 8. And then obviously from here we can solve this proportion here. Okay, so we'll have h is equals to 8 multiplied by 6 over 10, and 2 goes in there 5 times, goes in there 4 times. 6 multiplied by 4 is 24 divided by 5. Okay, so sometimes there is much easier method than Pythagoras, even when we deal with right-angled triangles. Question says, quadrilateral triangle ABC is shown alongside. The center G is joined to A, B, and C, forming 3 identical triangles. D, E, and F are midpoints of AB, AC, and BC respectively. If the area of triangle ABC is 120 square centimeters, what is the area of the shaded region. Okay, so now first of all, let's look at these 4 triangles that I'm going to highlight in green. So all those 4 triangles are congruent, okay, or they are exactly the same. Now we know that the total area of ABC is 120. So if we take 120 divided by 4, we get 30 square centimeters. So that's the area of each of these triangles there. Okay. So now we can see that from triangle ADE, it's also divided into 2 equal parts because that line goes straight into the center of the triangle. Okay. So now this shaded region is actually half the area of ADE. So we know that the area of ADE is 30. So we'll take 30 centimeters squared. We further divide it by 2 to get 15 centimeters squared. And that's one of the areas that is shaded. Okay. And then if we go back and look at the triangle DEF, it's divided into 3 equal quadrilaterals. Okay, and we know that the area of DEF is 30. Okay, we just calculated it there. Now we take 30, divide by 3, and we get 10 square centimeters, and that's the area here, the little area here. Okay, so that is also an area that is shaded. So if we add all the shaded area, so the area of all the shaded will be equals to 15 plus 10, which our answer becomes 25 square centimeters. Okay, this one was a little easier. Okay, this question says AC and BD are diameters of the circle. AC is equals to BD, which is equals to 6 centimeters. If the area of the shaded region is 7 pi centimeters squared, find the value of X. Okay, now we know that AC is a diameter and they are equals to 6. That means the radius of this circle here will be equals to 3 centimeters. And the area of the circle, we know that's pi r squared, so which will be equals to pi 3 squared, and we get 9 pi. Right, so this is the area of the full circle. We are given the area of the shaded region. So the area of unshaded, the area of unshaded region will be equals to area of the circle minus the area of the shaded, and we get 2 pi. Okay, so we can see from our diagram here, if we say this angle here is theta, that will also be theta because they are vertically opposite. So that means the sector here, the area of this sector is equals to the area of that other sector. So each sector will have an area equals to pi. Okay, so we can conclude that each sector will be equals to pi. Okay, now area of a sector is equals to theta over 360 multiplied by the area of the circle. Theta being the angle here forming the sector. Okay, so this is how you calculate the area of a sector. Now, we know that each sector has an area equals to pi, so we can equate this to pi because we know the radius already and we can find the angle theta there. So, we have theta over 360 multiplied by pi, radius is 3 squared, must be equals to pi. Okay, so from this pi will obviously cancel pi, and theta will be equals to 360 divided by 9. 360 divided by 9 is equals to 40 degrees. Okay, now we know that theta is 40 degrees, and so we can write 40 degrees there. But because we know that this is a radius, this is also a radius, so we know that this triangle here is actually isosceles, meaning this angle here at B should also be x. Okay, so this should also be x. Now, using sum of angles in a triangle, we can now say 180 is equals to 2x plus 40, and then 2x will be equals to 140. So x will be equals to 70 degrees. Beautiful question.